And while I have you, are you up for just one more little tweak that we can add on top of dynamic ARP inspection? Because it's pretty cool. What happens by default when DAI, dynamic ARP inspection, is installed or enabled is that it rate limits ARP traffic on a port to 15 ARP messages per second. Now that seems like it should be adequate for any normal activity, but if somebody's doing something malicious like a ping sweep of the whole network and they're trying to ARP for every single IP address in that subnet, they could be cranking a lot higher rates than that, and dynamic ARP inspection can stop that. So the default rate limiting is 15, so I'd like to show you where you can go to see that and also how you could change it. So the way that we could see the current rate limiting for dynamic ARP inspection is with the command show IP ARP inspection, and then the keyword interfaces, and press enter. And this will also show whether or not the interfaces are trusted or not. So gig 33 we specifically made as a trusted port from a DAI perspective. And then the rate, packets per second, regarding all ARP traffic on the untrusted ports is 15 packets per second by default. And if we wanted to change that, we could go to interface gig 0/1 and do an IP ARP inspection, question mark, limit, space, rate, space, and then the rate we want to give it. So let's say we wanted to, for some reason, allow up to 100 packets per second on that interface regarding ARP traffic. We could put that in, then use the up arrow key and do that command again and verify that it made the change. Now, just for fun, if we wanted to test that, what we could do is go to our Kali Linux box in the lab, and here at the Kali Linux box, we could just do a simple nmap. So with nmap, we can do a sweep of the network, and we can just try to find all the devices that are there. And if there's 254 possible addresses, it's going to do ARPs for 254 addresses. And that's very likely going to trigger even our 100 threshold within a second. So we'll put in 10.16.20.0 with the 24-bit mask. And I'll work with my numlocks there. Darn it. All right. With my numlocks adjusted, 10.16.20.0/24. Great. And we'll go ahead and do our scan. Now, if we go back to the console at dcnug, if we violate that, it'll let us know. And sure enough, there it is. 103 packets received in 630 milliseconds. That port is now in error disabled state. So we do show interface status, error disabled, press enter, and there it is. And to bring it back up manually, we'd go into configuration mode, interface gig 0/1. We do a shutdown and a no shutdown. And that will bring it back up. And while we're here, let's go back to the Kali Linux box and let's do one more fun little thing. So here's the Linux box. There's a tool called ARP spoof. And if we press enter, it's pretty straightforward. You type in ARP spoof space -I, the interface you want to use. We're going to use Ethernet 0 space. And then a quick way of doing it is putting in the default gateway's address. This is mean, but 10.16.20.7, I believe, is R3's address. Let's go check that out real quick. So we'll go over to R3, just do a show IP interface brief. Sure enough, for VLAN 30, that's his IP address. So if we go back to our Kali Linux box and we do this command, what this is going to do, this is going to send out a broadcast response, an ARP response, claiming that the layer 2 address of 10.16.20.7, the default gateway, is the layer 2 address of Ethernet 0 on this Kali Linux box. And it's just going to go on until we stop it. So there you go. So it's sending that out as a broadcast over and over and over again. But great news, everybody. We've got dynamic ARP inspection enabled. So let's go take a look at the switch console. So back here at our switch, that is just being denied again and again and again. Now, this is not putting the port in an error disabled state. It's just denying all of those ARP messages that the Kali Linux box is trying to pump in there. And they're being denied because he's lying about the layer 3, layer 2 mapping in his ARP messages that he's sending as broadcast into the network. So we'll go back to the Kali Linux box and we will do a Control-C to stop that. And if we go back to our admin PC and we'll do a show log and then hit space a few times, we can just ruminate on all those denies due to dynamic ARP inspection doing a great job of protecting the network. And there's actually just one more tip that I'd like to add regarding DAI, dynamic ARP inspection, to make it even more secure. Check this out. On the switch, if we do a show IP ARP inspection for VLAN 30 and press enter, you'll notice that it's enabled, We've got our access list, but these three options right here, source MAC validation, destination MAC validation, and IP address validation, those are disabled by default. So in addition to dynamic ARP inspection's normal job of looking at ARP responses, and then if they're not valid IP to MAC mappings, dropping those, it can also do these three additional validation checks. But they're not enabled by default. For source MAC validation, dynamic ARP inspection is going to check the MAC address in the layer 2 header against the sender MAC address in the ARP response. For destination MAC, it's going to check the destination MAC address in the Ethernet layer 2 header against the target MAC address that's part of the ARP response. And for IP, it's just looking for unexpected, like bogus types of IP information that might be included as part of an ARP response. And to enable them, it's a one-liner. So if we go into configuration mode, IP ARP inspection, we simply add the command validate, and then we add the options that we want to validate. Destination MAC address, IP information, and source MAC address, just like that. And we press enter. Then if we do an up arrow key again for that same command, show IP ARP inspection for VLAN 30, now those three additional checks are being done regarding ARP messages. So as a result of our time together in these videos and labs, we've had the opportunity to configure ARP inspection a couple times, configure ARP access list as additional information for dynamic ARP inspection to map out the layer 3 and layer 2 mappings in addition to what's in the DHCP snooping table. We've also had a chance to verify the results. So I've enjoyed having you in this journey through the world of dynamic ARP inspection, and I look forward to seeing you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.